Hello viewers, so today we are going to wind off our series on Combined Science Paper 2, which is a specimen paper. I uploaded the solution for section A and section B, so today I'm going to upload the solutions on section C and section D. So in section C, candidates are required to answer N2 questions. But as we are doing our revision, we are going to answer all the questions. So number 10, it is reading, Table 10.1 shows the effect of three substances, A, B, and C, on universal indicator solution. So in A, we are having our indicator solution being red, and in B, we are having our indicator as green, and in C, our indicator is purple. Part A1, state the function of the universal indicator solution. So a universal indicator is a paper that has various colors that can be used to measure a pH value in a solution. Part 2, deduce the nature of substances B and C. You should understand this when using the universal indicator to measure a pH value in a solution. If the solution is strong acidic, the pH is going to be less than 3, and the indicator is going to be red in strong acidic solution. And then from pH, which is 3 to 6, it is weak acid, and the universal indicator is going to be yellow or orange. When the solution is having a pH which is 7, and that 7 is known as neutral solution, the color of the universal indicator is going to be green. From 8 to 11, the solution having a pH which is ranging from 8 to 11, it is described as a weak base, and the universal indicator is going to be blue in weak alkali. If the solution is pH which is greater than 11, it is described as a strong alkali, and then the universal indicator is going to be purple in strong alkali. It is now easier to answer our question, which is requiring us to deduce the nature of substances B and C. So B is neutral, while C is a strong alkali. Part B, dilute hydrochloric acid is reacted with magnesium carbonate. State the type of reaction. This type of reaction is known as neutralization reaction. Part 2, write a weight equation of the reaction. So you should not confuse the weight equation and the chemical equation. A weight equation, you are supposed to write the equation in words, and a chemical equation, you are supposed to write in using the chemical symbols. So in our weight equation, we are going to write that hydrochloric acid is reacting with magnesium carbonate in order to form magnesium chloride, which is a salt, plus carbon dioxide plus water. So this is the weight equation for the reaction of hydrochloric acid with magnesium carbonate. I'm going to write also the chemical equation so that you understand. But in this question, you are required to write weight equation, not chemical equation. So if it is chemical equation, we're going to write hydrogen chloride is reacting with magnesium carbonate in order to give us magnesium chloride plus carbon dioxide plus water, and we need to balance our equation. We're having one chlorine at the side and 2 chlorine here, so it means we need to place a 2 here. By doing this, it is now a balanced equation: 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine, one magnesium, one carbon, one carbon, 3 oxygens, 2 plus 1, 3 oxygens. So it is now a balanced equation. Let us move on to the next question. Number 10C. The chemical equations for two redox reactions are given below. We're having iron 2 chloride reacting with chlorine in order to form iron 3 chloride, and also we have copper 2 oxide reacting with hydrogen to obtain copper and water. So we need to define oxidation in terms of oxygen. So oxidation is defined as the gain of oxygen. For example, in this case, we have this hydrogen. It is oxidized in order to obtain this water because it has gained oxygen to become water. In part 2, we want to define oxidation in terms of electron transfer. So in terms of electron transfer, oxidation is the loss of electrons. This occurs when a metal reacts with a non-metal. For example, if you react magnesium and oxygen, magnesium is going to lose electrons to oxygen for them to obtain octet configuration, both of them. So by doing that, magnesium is being oxidized by losing those 2 electrons. So you should also know how to define oxidation in terms of hydrogen. In terms of hydrogen, it is going to be the loss of hydrogen. And then on part 2, state what happens in terms of oxidation and reduction to iron chloride and copper oxide in the 2 redox reactions. So in iron 2 chloride, oxidation is going to happen to iron as it loses its 2 electrons to chlorine, forming iron 2 plus iron. So this is what is happening. We are having our iron being converted to iron 2 plus 2 electrons, and then we are having this chlorine, right, taking those 2 electrons in order to form a chloride ion. Let me explain again. This is what is happening. We have our iron 2 chloride. Iron is going to lose 2 electrons. By doing this, it is oxidized. And then we are having chlorine gaining those 2 electrons in order to form chloride. By doing that, it is being reduced. Let's move on to copper 2 oxide. So this equation, the equation number 2, is a classic example of redox reaction in which copper 2 oxide acts as oxidizing agent involving oxidation of hydrogen gas to water. Idea here is that copper 2 oxide will oxidize hydrogen gas to water while it's being reduced to copper metal in the process. Let us assign the oxidation number to all the atoms that take part in the reaction. We can see that copper's oxidation number, it is +2. In the reactant side, it is +2, and then in the product side, it is 0. So reduction is occurred because we can see the decrease in oxidation number. Let us assign the oxidation number of hydrogen. It is 0, but in this water, it is now +2. So we can see that hydrogen was oxidized as it has gained oxidation number from 0 to 2. So in summary, copper 2 oxide was reduced to get copper. It has lost the oxygen and oxidation number decreases from +2 to 0. And then hydrogen was oxidized as it has gained the oxygen, and also its oxidation number increases from 0 to +2. So that was all about number 10 on the specimen paper Combined Science. Let us move on to number 11. Number 11, Fig 11.1 shows the blast furnace used for the extraction of iron. So in 11a part 1, we are supposed to name the substance that enters the furnace through S. So this is what I'm going to do, guys. I'm going to label all the parts on the blast furnace so that you understand the process that happens in the extraction of iron in the blast furnace. So at this point, we are going to input coke or carbon, and then limestone and our iron ore. So at this point and this point, we are having hot air being entering in the blast furnace. It is hot air or oxygen. So this point is the exit point of molten sludge, and this point is the exit point of molten iron, and these points are the point of exit of waste gas. Let us now answer the questions. Name the substance that enters the furnace through S. So it is hot air, or we write oxygen. And then on part 2, we are supposed to state what is released through R. It is waste gas. Let us move on to the next question. Number 11b, part 1. Describe the main reactions which occur in the blast furnace. I'm going to use the diagram which is at the back of the page to explain the main reactions which occur in the. Hi guys, I realized that I was on mute when I was supposed to describe the reactions that occur in the blast furnace. So I have to edit the video. So first we are having coke or carbon burning with oxygen to produce carbon dioxide. And that carbon dioxide is going to react with coke to give carbon monoxide. Carbon monoxide is going to act as a reducing agent and reacts with iron ore to give molten iron. Limestone decomposes to make the sludge which floats on top of the iron ore and can be removed. That are the main reactions that are okay in the blast furnace. And then on part B2, I was supposed to explain the advantage of having sludge covering the molten iron. So it is going to protect iron from oxidation by the atmosphere, and this keep iron clean. Let us move on to part C. A sample of iron oxide was found to contain 70% iron. Find the empirical formula of the iron oxide. So we are having two elements present, that is iron and oxygen. First of all, we need to find the number of moles of the elements which are present. So to find the number of moles, we are going to say the given percentage divided by the molecular mass of the elements present. So the percentage of iron is 70%. It implies that the percentage of oxygen is 30% in order to get 100%. And then the molecular mass of iron is 56, and then that of oxygen is 16. Let us punch on the calculator 70 divided by 56. 70 divided by 56, we are obtaining 1.25. And then 30 divided by 16, we are getting 1.875. We are going to divide by the lowest number of moles, which is 1.25. So we divide by 1.25 here, and then 1.25 here. If we say 1.25 divided by 1.25, we get 1. And then if we say 1.875 divided by 1.25, we are getting 1.5, which is 3/2. So to remove this fraction, we are going to multiply all the terms by 2. We multiply by 2 here, by 2 here, so that we now have 2 ions and 3 oxygens. So this is how we are going to present our answer. We are going to write ion, we put our 2, and then oxygen, we put our 3. So it is iron 3 oxide. This is going to be our empirical formula. So that was all about number 11 on the specimen paper. Let us move on to number 12. Number 12, the flow chart in Fig 12.1 shows the stages in the manufacture of sulfuric acid. Name the industrial process that produces sulfuric acid. So it is known as a contact process. Part 2, describe the production of sulfur dioxide in stage 1. So this is what happens. We are having our sulfur, or we are going to use iron pyrites. We burn them in air to form sulfur dioxide. So the chemical reaction of this process, we are saying sulfur plus oxygen in order to get sulfur dioxide. And then in part 3, state 3 conditions required in stage 2. The stage 2, we are having our sulfur dioxide reacting with oxygen in order to form sulfur trioxide. And the process is reversible. So we are going to put the sign, a reversible sign, to represent the equation. So for our equation to balance, we need 2 moles of sulfur dioxide reacting with 1 mole of oxygen to obtain 2 moles of sulfur trioxide. And then the conditions that are required, we will need, for this reversible reaction to occur, we need a catalyst to speed up the reaction. So the catalyst that is used is vanadium pentoxide. Its chemical formula is V2O5. The pressure that is required is 1 to 2 atm, and a temperature between 400 to 450 degrees Celsius is required. Part 4, explain why stage 3 is necessary. In this stage 3, we are having oleum being produced. So dilution of sulfur trioxide in water can yield sulfuric acid. This is, however, dangerous and hence not followed. The addition of sulfur trioxide to water is highly exothermic, and it causes the fuming of sulfuric acid, and the fumes prevent the further dissolution of sulfur trioxide in water. So the accepted method is to dilute sulfur trioxide in concentrated sulfuric acid to produce oleum. On part 4, we want to name the substance X, the substance that is going to react with sulfur trioxide to get oleum. It is sulfuric acid, concentrated sulfuric acid. And then number 12A, part 4, we are supposed to write, part 6, we are supposed to write an equation for the process occurring in stage 4. Number 12A, part 6, write an equation for the process occurring in stage 4. So they didn't specify weight equation or a chemical equation. So we are going to write any of the two, either a chemical equation or a weight equation of the process that is occurring in stage 4. So this is the stage 4. We are having oleum reacting with water to produce sulfuric acid. So I'm going to write equation in weight and in chemical. So in stage 6 we are having oleum plus water to give us sulfuric acid. So I'm supposed to write a weight equation throughout. And then when you're writing in chemical, using chemical symbols, we are saying oleum is H2, S2O7, that is reacting with water for us to have 2 sulfuric acids. And then on part B, we are supposed to state N2 uses of sulfuric acid. So there are so many uses of sulfuric acid. I'm going to explain some of them. So sulfuric acid is used in the manufacture of fertilizers. It gives rise to phosphoric acid, which produces phosphate fertilizers. Sulfuric acid is also used in the manufacture of batteries. It is used in ointments to treat various skin infections. It is used in the paper industry for the manufacture of aluminium sulfate. It is used to damage cancerous cells' DNA by the manufacture of chemotherapy drugs. It is used in the production of cleaning agents. So there are so many uses of sulfuric acid. In this question, we're supposed just to state N2 uses of sulfuric acid from all the uses that I have listed. So this marks the end of the chemistry section. Let us move on to the physics section. In this section, candidates are required to answer 2 questions, but as we are doing our revision, we are going to answer all the questions. Number 13A, part 1 is reading, state the Newton's first law of motion. So the Newton's first law of motion, referred to as the law of inertia, states that an object at rest remains at rest and an object in motion remains in motion at constant speed and in straight line unless acted on by an unbalanced force. Part 2, explain why a book sliding and experiencing a frictional force of 9 newtons keeps on sliding across a desk. So it is going to keep on sliding due to kinetic frictional force, also known as sliding friction between the book and the surface of the table. So this kinetic frictional force is force that is needed to keep a surface sliding on another surface. Part B, a block of mass 2 kg is accelerated by a force of 4 newtons. Calculate the acceleration. So we know that force is equals to mass times acceleration. So we are going to make the acceleration the subject of formula by dividing both sides by mass. So this mass is going to cancel this mass, and then the force is 4 newtons, and then the mass is 2 kg. If we say 4 divided by 2, we are going to obtain 2, and the units for acceleration is meters per second squared. See part 1, state 3 events which occur in the power stroke of petrol engine. When piston ascends, it reaches top dead center. Electric current ignites the spark plug and the mixed the mixed gas burns. It expands and builds pressure in the combustion chamber. Resulting pressure pushes the piston down with several tons of force. Let me repeat again. When piston ascends and reaches top dead center, electric current ignites the spark plug, and as the mixed gas burns, it expands and builds pressure in the combustion chamber. Resulting pressure pushes piston down with several tons of force. And then on part 2, we're supposed to state one advantage of modern petrol engines over the old petrol engines. So modern engines are much smarter, smaller, more powerful and more efficient than the old petrol ones. Let us move on to the next question. Number 14a, define the term telecommunications. So telecommunication are the means of electronic transmission of information over distance. Information may be in the form of voice, telephone calls, data, text, images, or videos. In part B, we are supposed to give 2 examples of telecommunication systems. So the 2 examples of telecommunication system, we have telephone network, radio broadcasting system, computer networks, and the internet. So from all these examples, we're just supposed to write any 2 examples of these examples. And then let us move on to part C. Fig 14.1 shows the components of a communication system. Name the components A and C. So on A, we are having a sender or a transmitter, and then on C, we are having the receiver. And then on part 2, we are supposed to describe the functions of component A, which is the sender. So the sender creates the information, take information and convert it to a signal. Part D, describe 2 advantages of a cell phone over a landline. So the first advantage that I'm going to describe is that of entertainment. You can play games, stream online, watch videos, read books, listen to music, whereas in landline, it is just for receiving the calls. Another advantage that I'm going to explain is you can do online banking using the cell phone. You no longer have to visit the banks to carry out transaction. It allows you to transfer funds, receive cash, check your account balance, and pay bills. The other advantages of cell phone over a landline is that they are small in size, so they can be easily fitted anywhere, in handbags, even clutches. Mobile phones let you share images, videos, gifts, and memes with friends and families. Text messaging allows people to send letters, numbers, symbols through written messages on mobile phone. So that was all about number 14. Let us move on to the final question, which is number 15. Number 15a, Fig 15.1 shows the energy conversion in a thermal power station. Name a possible primary source of energy in Zimbabwe. So the possible primary source of energy is coal, and the main thermal power station in Zimbabwe is in Hwange. Part 2, state 2 disadvantages of the energy source named in part 1. So the first disadvantage is coal is non-renewable source of energy. Another disadvantage is it emits toxic and carcinogenic substance into our air, water, and land, affecting human health. Another disadvantage is coal causes greenhouse gas pollution. So there are so many disadvantages of coal. We're just supposed to state any 2 disadvantages of using coal as source of energy. And then in part 3, give the form of energy represented by A. It is thermal energy. Thermal energy is also known as heat energy. Let's move on to the next question. Number 15A, part 4. Describe what happens at stage 3 and 4. In stage 3, we are having this steam turbine, and then in stage 4, we are having transformer. So we are supposed to explain what happens in these 2 stages. So steam turbines works by using a heat source to heat water to extremely high temperatures until it is converted into steam. Then steam turbines conveys the heat energy of steam into mechanical energy. So now I want to explain what happens in the transformer. Transformer conveys the generated electricity to higher voltage to make long distance distribution possible. And then finally, state the energy conversion in a hydroelectric power station. State the energy conversion in a hydroelectric power station. Hydroelectric power station conveys potential energy stored in water reservoir behind a dam to mechanical, also known as kinetic energy. This marks the end of our revision on specimen paper, which was written in 2018. Thank you so much, guys, for following me on this channel. I value your views, I value your subscriptions, I value your comments. Continue to support me for my channel to grow. I love you all. This is Eve signing out. Let us meet in more revisions which are on their way.